interesting research paper, Evolving Self-Assembling Neural Networks from Spontaneous Activity to Experience-Dependent Learning, and it's put out by IT University of Copenhagen in Denmark. And this paper is really on the edge of, let's say, like philosophy and cutting-edge AI research, which for most people it would kind of like throw it out. And so for me, this is like the perfect research paper, right? This is especially for this channel. So I found this. It took me a few weeks to find it, but this is a great research paper overall as far as what it actually covers and their research overall. So I'll dive into it. The bottom line is that they create a new method. They call it LNDP, Lifelong Neural Developmental Programs, LNDP. And then essentially it's a mathematics. There's a lot of mathematical algorithms and mathematical framework behind it, right? And then like every time that so I mean, if you call LNDP, PFAF, no matter what it is, right? Like these fancy names, they're just fancy names for algorithms. Like you don't want to talk about the math all day, right? And you don't want to talk about the math at all. So it's just this is called LNDP, and then so like let's just kind of ignore the math. It's generally like how that goes, right? But so the math of it is really straightforward overall. It utilizes transformers and graph neural networks and GRUs. And then so those are like the three overall pieces of technology. And then kind of how it works is, so they introduce this concept of spontaneous activity. And then it's modeled 100% off of neural plasticity within the human brain. And framing this out, like the concept that I give for it, how I frame this in my head is, this is a very known concept and it's not scientifically known, right? So this is kind of an interesting concept to me. Like it's in the field of psychology and we don't understand why it happens. But so if I want to practice shooting a basketball, if I close my eyes and I imagine shooting a basketball 10 times, like I go through and I imagine the motions, right? I imagine every single part of it, and then I go and I do it, I'm going to perform better than if I just did it cold. Like if I just went into the activity like with nothing there, right? Just purely imagining doing the activity allows for some sort of benefit. And then so a big part of this LNDP process is so the goal, there's a few things. One, this incorporates meta learning. So meta learning meaning that the model can learn from experience, and then which is very new breakthrough technology, right? But so within that, what they do is they encode kind of that same way that you would think about the activity before you actually perform the activity. And then so that's what this spontaneous activity is, and it takes place before the model performs an activity. And think of it like a soft reset, right? Like a soft reset, and it frames the activity. If it's playing basketball, then it imagines shooting the basketball. If it's playing a chess match, it imagines playing out the chess match. And then what it does within that is it sets initial weights, and then it'll set like an initial expectation off of that, right? And then from there, it'll adjust its weights and it'll go through and oh, okay, I was wrong here, there, etc. Right? Like exactly like a person would do. Which is interesting framework overall. And then so, again, how they do that and how they get the model to do this is very straightforward overall. Again, as far as it's just graph neural networks is what it's using, and then that mechanism, that gating mechanism, real-time mechanism is GRUs. And then so GRUs plus GNNs in combination with a little bit more math is what leads them to get to LNDP overall. As far as like a bottom line, like just stripping it all down, right? That's the distillation of it. And within this, it's a pretty straightforward framework overall, and it works. And they provide good benchmarks overall that this is a better method overall than RLHF, or reinforcement learning with human feedback, right? This is like reinforcement learning from environmental feedback, like RLEF is what I would call this. And then the goal of it is to give the model structural plasticity. If you look at like the psychological studies, what we know about this scientifically around the brain, these areas and this area is related to neuroplasticity within the brain. And then so this is their attempt of artificial neuroplasticity overall. And then so that's a good summation of the paper overall and the research here. To me, this I will touch on this because it hits on philosophical issue around this that I've thought about for a long time around this, and it's interesting to bring up. And then so within this channel, like I try to do the blend of academic research and philosophy, right? So this is it's rare that I get the opportunity to do both in a singular video, but within this, the philosophical aspect that this kind of brings up for me is this aspect of desire, and I've pondered this aspect a lot. I think, like, I'll go on the record, like I think it would be very philosophically bad, like one of the worst things that we could do if we accidentally imbue AI with desire without knowing how desire works. And like, so I don't, I think about, like, to me, I think about what could go wrong, right? And then like when I think about like what could go wrong with regards towards intelligence, and then what could go wrong with regards towards intelligence is like you have like some bad actors that exist sometimes, right? Like there's like serial killers that exist, like mass, like people that do bad things, and then so it's like what can possibly set them off of the rails, and then like you can, I mean, it's nature and nurture, right? And then so that's an element of it, but like stripping it down, like the core essence, like what is required at that, like to spin it all into motion is desire, and then if you have desire in there, like you can, if you spin the wheel enough, like you're going to get something out of it, right? And then to me, like, so it's there's two questions within this, right? Like the question of, is desire emergent, and then if not, what exactly is desire? Like how exactly does desire come about? And then like to me, this research gets very close to desire, right? Because so in order for this meta learning to exist and this learning from the environment to exist, it's, as I mentioned, GNNs and GRUs, right? And then the third kind of aspect of it is that, and I should have highlighted this before, is that the model does have to update the attention and the reward mechanism in real time, right? And then so to me, that gets that, when you start getting into that conversation and around those issues, that's when you start getting into this issue of like, that's possibly desire. Like I don't know what desire is, but to me, like desire is just updating your own reward mechanism. If you look at like the biological reward mechanism, I'll call it, it's pretty simple within biological species to me overall. Like if you look at like I'm gonna mess this up, but there's like a species of like, I think it's ducks, right? And then they're like really attracted to like red, and then they're like if you like and there's like a, if you give it like the red like type of fish that they'll go after, right? And then if it's like you give it like a balloon that resembles this red fish, it'll go after that like 1,000,000% of the time, just because it triggers their reward mechanism so hard in their brain, right? And it just like they'll go off on it, and it's like um, there's a lot of examples of this where it's like very easy to like um, artificially stimulate the biological reward mechanisms in brain, like drugs, things like that do that overall, right? And then so once you get into that, I think it's bad to play around with that with regards towards AI models. Like we don't know how that works in our brains, and then we don't know enough. Like, like I don't know. It's just my overall takes and philosophies. I think we should. There's certain areas where we should take a slow approach because we just don't know, right? We don't know what we don't know, and like there's no harm in understanding and taking time to understand what we don't know. And then so um, with that overall though, like this is an interesting leap forward. I bring this research paper up and talk about it overall because so from a philosophical standpoint and philosophical implications, if they're correct within their research, which I mean, I think if you follow a lot of my kind of research and how I go along with that, I cite this paper and I bring up this paper because I think that they are probably correct with their research. The philosophical and the real world ramifications of it, this are that they create like a framework for neuroplasticity overall for models, which like could be really cool. It could be increased generalizability in AI models overall. So that's kind of like what we're looking at here as far as possible implications of this paper. Or it could be nothing, right? That's why I like these types of papers overall. It could be the next groundbreaking thing, and we'll be talking about it 50 years from now, or like we'll never talk about this paper again. And it'll be one of those two. And so with that said, hope you like this type of video, and like if you like this type of content, please like and subscribe. Thank you much.